Hello students, I am Sonali Kelkar from City International School, and today we are going to do the 6th revision of the science chapter. In today's revision, I am going to take few important diagrams of physics. So let's start today's session. Okay, we'll deal with the important physics diagrams in this session, as I've told you. Okay, the first diagram is verification of Ohm's law. Ohm's law states that under constant temperature, in fact, under the constant physical condition, the current passing through the conductor is directly proportional to the potential difference across it, right? So we can derive this particular formula. This can come for 1 mark, right, where we have to derive that the current is proportional to the potential difference across the wire. So I will write V proportional to I. Okay, and if you are writing I proportional to V, because as we say current proportional to the potential difference, usually we write starts with I proportional to V. You can just flip it, make it V proportional to I, because my formula will be V. I have to introduce is equals to sign to remove the proportionality sign. So whenever I remove the proportionality sign, I have to introduce one constant, and in this formula my constant is resistance, right? So resistance, if I keep the resistance constant, in that condition the current which is flowing through the conductor is directly proportional to the potential difference across it. Okay, so V is equals to IR. I will put I here, I and R I have introduced, right? So now coming to the diagram. Okay, here we can see the diagram. The battery is positive terminal and negative terminal of the battery, which is very important. Okay, current flows from positive terminal towards the negative terminal. So you have to make sure how the current is flowing. Then you have to attach a ammeter. Ammeter is an instrument which measures the current. The positive side of the ammeter should always connect to the positive side of the battery. Okay, so these are the small things, but you have to keep in mind. Then there is a resistance denoted by capital R. Okay, always denote resistors by capital R. Then this resistor, across this resistor I have I have connected one voltmeter. Again, how the voltmeter is connected, the positive terminal of the voltmeter and the positive terminal of the battery should be on the same side. The negative terminal of the voltmeter and the negative terminal of battery should be on the same side, right? If you can see, the positive terminal of the battery is on the left hand side and the negative terminal is on the right hand side. Even in case of the voltmeter, it is a positive, left hand side positive, and the battery, the negative terminal is on the left hand side of the battery, right? So this is how we have to arrange our different instruments in the diagram or in the circuit. Coming to the next diagram, refraction of light through a glass prism. There is a glass prism over here, right? This glass prism, as you can see, it is made up of three surfaces, three plane surfaces. These three plane surfaces are joined together, and there is an angle made between each surfaces. This angle is very important to draw this diagram or to find out the refraction of light in the glass prism, right? So if I take a light, you have to draw a light, one ray of light. This is a monochromatic ray of light, okay? And there should be an angle between the surface and the light. Surface and light, there should be an angle between the surface and the light. And what you have to do is on this surface you have to draw a normal. Okay, why we have to draw the normal? Because there will be a refraction of light. We have to see when the light passes from the rarer medium, this is air, from medium to the denser medium, which is a glass, it always move towards the normal. Okay, So this is my normal, and the light is moving towards the normal. As you can see, the light is moving towards the normal. If I extend that light ray, it is going straight on this direction, and this is my normal, right? The light is moving, the ray of the light is moving towards the normal when it passes from rarer medium to the denser medium. Okay, you have to extend this ray of light, and again there is a junction where the light is moving from the glass and it is going out to air, the medium, which is rarer medium. From denser to rarer medium, when light goes, it moves away from the normal. Again, you at this point you have to draw a normal, right? And you can see that the light has moved away from the normal, and this is how you have to show the diagram, which is an important diagram which can come in exam for 2 or 3 marker. Another diagram. Here we have to discuss the dispersion of white light by glass prism. So when a beam of a light, and we can say a monochromatic light, a beam, you have to take a beam of light, okay? When a beam of a light is passed through a glass prism, it splits up into a band of colors called spectrum. And this is called the dispersion of white light. The spectrum of white light has the color which are violet, indigo, blue, green, yellow, orange and red, Vibgyor. Okay, but when you draw the diagram, you make sure that red light is the least deflected light, okay, from its path. So red is always coming at the top. So Vibgyor, you are going to start writing from the down, Vibgyor, because I have seen that student had made mistake in drawing the spectrum of the white light. Okay, they started from Vibgyor, V at the top, which is absolutely wrong. Okay, R should come at the top and V should come at the bottom, because V is deflected most during the time of dispersion of light. Okay, so here's the diagram. You have to draw a proper prism, sunlight or the bulb light, and you have to write a beam of white light over here, and you have to show how the lights, how the different light which constitute the white light, they get dispersed in the glass prism. And you have to show a white screen. Please label the white screen properly, and then you can show the different bands of colors, that is Vibgyor on the screen, which collectively known as a spectrum. Next diagram, recombination of a spectrum of white light. It is another very important diagram. Okay, here what we have done, when a beam of a light passes through the prism, okay, it gets scattered. We have seen it get dispersed and it split up, but when I keep another prism inverted, okay, another prism which is in an inverted position, I will see that the beam of light, they combine together, and at the end on the screen I can able to see only the white light. In the previous slide we have seen that when a beam of a white light passes through the glass prism, it gets dispersed, and on the screen I can see the 7 different colors. But if I put another prism and the position is definitely inverted, I see that those dispersed light, okay, they combined together, and on the screen I can see now a white light. So this is a very important diagram and important phenomena of white light. Now let's see the another diagram, that is rainbow formation. In the rainbow formation, we know that rainbow formation is a natural phenomena, and where we can see the spectrum appearing in the sky after the rainfall. There should be a sun right? And we have, when we are drawing the diagram, we should be very much careful that sun should be on the sun should be behind a person, right? So if you make a person over here, or if you make a eye, or if you draw a eye over here, make sure that the sun is behind the person, always behind the person. And when light from the sun strike on the raindrop, now these raindrop acts like a prism, right? And inside the raindrop, what is happening? Dispersion of the light is taking place. You can take two color light, that is red and violet, right? And you can see there is a total internal reflection. Rays got reflected inside, fine. And there will be a deviation at the junction of the two medium. First, the ray of a light was passing from rarer to the denser medium, so it bent towards the normal. As you can see, the bending taking place over here. And from denser to the rarer, it bends away from the normal, as you can see over here, the violet light and the red light. Okay, the violet light is deflected more and the red light is deflected less. And this type of when there is a dispersion of white light in the sky with the help of a raindrop, then we will see a rainbow in the sky, right? So these water drops acts like a prism. They refract and disperse. In first case, what is happening over here? Refraction. Okay, the refraction is taking place, so they refract and the dispersion is taking place inside the raindrop. Dispersion. Okay, they get internally reflected from here. They get reflected and then they came out again. Finally, refraction takes place. They come out due to the dispersion and internal reflection of the sunlight. By the water droplet, we can able to see a rainbow. Important diagram is refraction of light through rectangular glass slab. Okay, now when a light ray enters in the glass slab, then the emergent ray is parallel to the incident ray because it is shifted sidewise. It has shifted sidewards. Okay, yes, you can see over here in this diagram, this is the incident ray, okay, which is supposed to go straight like this, but because of the action, this incident ray had moved towards the normal. Why it has moved towards the normal? Because there is a change in the refractive index. Why there is a change in the refractive index? Because there is a change in the optical density of the two medium. Air is optically rarer medium and glass is optically denser medium. And when a light moves from optically rarer medium to the denser medium, it moves towards the normal. As the incident ray has shifted towards the normal, and again we can see there is a point B where the refraction is taking place again. Why? Because again there is a change in the medium. Now the light is moving from the glass, which is optically denser, towards the rarer medium, which is air, which is optically rarer medium, and we can see the light has moved away from the normal, right? As a result, there is a lateral displacement. Now, what is a lateral displacement? The perpendicular distance, it is a perpendicular distance between the emergent ray and the incident ray when the light passes out of a glass slab. Okay, so this is what is all about our rectangular glass slab diagram. You have to label it properly. You have to label it properly. Labeling is very important, children. Incident ray, reflected ray, emergent ray, right? And you should show this distance, and this incident ray and the emergent ray, they are parallel to each other. Make sure they are parallel to each other. Don't draw any kind of diagram where it shows that they are somewhere meeting down. Okay, so they have to be parallel to each other. You have to label lateral displacement, which is very important. Then you have to label the air and the glass, which is the medium. Again, air, which is a medium, because there are two places where the refraction is taking place. Okay, then you have to show the angle of the incidence, angle of emergent, okay, and angle of refraction. Next topic is atmospheric refraction effect, and in this topic we have to do advanced sunrise and delayed sunset. Now even this diagram is very important diagram, where you have to draw the earth atmosphere, right? You can show a light coming from the sun, it gets refracted because the light is traveling from the denser medium towards the rarer medium. It is refracted inside, and because of this person can able to see the sunrise 2 minutes before the actual sunrise. Okay, so this diagram is again important diagram. Then you have to show the diagram where you have to say about the reddening of the sun at sunrise and sunset. We know why this phenomena happens, because when the light has to travel a long distance during the sunrise or the sunset, when it has to travel a long distance, then the small wavelength light, that is the blue, violet, indigo, it gets scattered away, and the only wavelength, the bigger wavelength, the longer wavelength light, that is the red light, is coming to us, which couldn't able to scatter much, and because of that we can see the redness of the sun during the sunset and sunrise. Okay, now why the sun appears white when it is overhead? Because now the light has to travel less distance, and by the time the light reach to our eyes, all the light of let's say the smaller wavelength and the longer wavelength light completely gets scattered, and because of that the sun looks white. Okay, now coming to the twinkling of a star, this is again tell about the refraction of light. We can see the apparent position of the apparent position of the star is different. The star looks little heighted, okay, from its original position. Why? It is again due to the refraction of light. As you can see in the diagram, you have to draw a particular diagram like this, where you have to show that how every layer of atmosphere, sorry, the light is getting refracted again and again. So due to this it is bending, and it is then coming to our eyes. But our brain is telling that our brain is going to take this ray of light straight back. Okay, and because of that we can see that star is at a different position, which is a little bit raised position, or this position is also known as apparent position, which is not the real position of the star. Now coming to the next important topic, that is the ray diagram. I have taken only the ray diagrams of a mirror, concave mirror and convex mirror. So before we do the ray diagram, we have to see the rules on which we are going, the rules on which, based on which we are going to draw our ray diagrams, right? So the first rule says that, so whenever the ray is parallel to the principal axis, I hope that you know what is the principal axis. This one is the principal axis, this line is the principal axis, okay, and here is a pole, and here is a focus, and if you want we can draw one over here, that is the center of curvature, right? Make sure that when you are drawing a diagram, the center of curvature and focus, the distance between the center of curvature and focus, and distance between the focus and the pole, it has to be same. Suppose you have taken 3 centimeter over here, you have to take the distance between focus and pole also 3 centimeter. So distance between the center of curvature and focus and pole has to be same. So while drawing this diagram you have to be very careful. Okay, so before the drawing of the diagram, let's do the rule. A rule says that when a ray of a light is parallel to the principal axis, after reflection, okay, I'll make a few lines over here which shows that the internal part of this mirror is a reflecting surface. So after reflect, this particular light goes through the focus. When a ray of light parallel to the principal axis, after reflection, it goes through the focus. Okay, after this you have to draw a proper arrow which shows the path of the light, right? The second rule, in case of concave mirror, when a ray of light, this is inverse rule, when a ray of light is passing through the focus, you can see the ray of light is passing through the focus. After reflection, it goes parallel to the principal axis. Third rule says that when a ray of a light inclined towards the pole, this is a pole, and this ray of light is falling inclinedly on the pole, it will reflect back, making the same angle. Okay, so my angle of incidence over here is equals to my angle of reflection. So my angle of incidence is equals to angle of reflection. We usually don't follow this rule because it is very difficult to make the two similar angles with the help of protector, and even if there is a single mistake, the diagram will get distorted. Okay, the diagram, you won't get the appropriate diagram. Now the second part is regarding the rules that we follow for convex mirror. Okay, this is for convex mirror, and this is for concave mirror, right? So in case of convex mirror, here also when a ray of light passing when a ray of light parallel to the principal axis, okay, after a reflection, it appears to go through the focus. After reflection, it appears to go through the focus. This is very important part. Okay, then when a ray of light passing through the focus, now if you can see the ray of light, this is ray of light. If I extend this ray of light, it seems that it is passing through the focus, appears to pass through the focus, right? After reflection, it goes back, and which is parallel to the principal axis. Here also a ray of light when inclined towards the pole, okay, it will go back, it will reflect back, making the same angle. Okay, the angle making the same angle with the normal. I can draw a normal. This principal axis works like a normal in this case, right? Again, we have to tell you the same thing. Try to avoid making use of this principle or this rule, because I don't want you to make mistake while drawing the angle of incidence and angle of reflection. Now coming to the different diagrams, these are the images of concave mirror. Let's take the first diagram where we can see that the object is at infinity. Okay, when the lights are coming through the object, you always have to draw the two rays coming from the object. Okay, without two rays you cannot form mirror images or the ray diagrams. So make sure that two rays should come from object to draw a proper ray diagram. So when we have to show that the rays are coming from the infinity, we can draw these type of two rays parallel to the principal axis, right? And after reflection, we have to use the first rule. After reflection, it passes through the focus, fine. When it passes through the focus, I have seen that at the focus, the image is a point size image. Okay, it is a point size image. So while writing the parameters, you have to write the position of the image, where the image is formed. So wherever the reflected lights are meeting, there the image is formed. The image is formed at focus. As you can see, what is the size of the image? It is a point size image, because these rays are meeting in real. So the image is also a real, and whenever there is a real image, it has to be inverted. Okay, and as you can see, it is highly diminished image. Okay, coming to the next diagram, here there is an object which is now beyond the sea, but it is on the principal axis, it is not at infinity. We have to take two rays coming out from this object, from the top of the object. Okay, after reflection, this ray is passing through the focus, right, and the second ray I will draw through the center of curvature, right. Whenever the ray is drawn through the center of curvature, it goes back to the same direction. Whenever the ray is passing through the center of the curvature, it goes back to the same direction. Why this is happening? Why does it happen? Because this ray this ray makes a normal with this point. Okay, I'll just try to draw a straight line over here. Okay, if I take this ray, it makes a normal with this, with the mirror. Okay, that is why it goes back to the same path. So here, wherever these two reflected ray are meeting, there you have to draw a image diagram. Here, because these rays are meeting in reality, so definitely the image is real. Whenever the image is real, it has to be inverted. So inverted, as you can see, this image size is smaller than the original size of an object. So I can write it is real, inverted and diminished. Where it is formed, as you can see the position, it is formed between the center of curvature and focus. Now coming to the next third image. When the object is at the center of curvature, so if I can keep an object at the center of curvature, so I'll take two rays coming out from the object. After reflection, this ray is going through the focus. The second ray, because the object is already at center of curvature, I cannot draw any ray which is passing through the center of curvature. So I will go for the second rule, that is, when the ray passes through the focus after reflection it becomes parallel to the principal axis. So wherever these reflected rays are meeting, there you have to draw a image. Because these reflected rays are meeting in real, the image is also a real. So we get a real image, inverted image, and as we can see, the size of the object and size of the image is same. Where the image is formed, it is formed at the center of curvature. Let's take the fourth ray diagram. When the object is between the center of curvature and focus, right? So when the object is between center of curvature and focus, as we can see here, let's draw two rays coming out from this object. The first ray is parallel to the principal axis. After reflection, it passes through the focus. Okay, and the second ray I can draw from the center of curvature, right? And this ray, okay, after reflection goes through the center of curvature, right? It goes straight through the center of curvature, and wherever they are meeting, these two rays are meeting, there the image is formed. This image is again, it is real, it is inverted, and as you can see, the size of the image is enlarged. It is more than that of the size of an object. Where it is formed beyond the center of curvature. Then let's do the fifth ray diagram. When the object is at focus, here we can see when the object is at focus, again I'll draw two rays. One is the principal axis. After reflection goes through the focus. The other ray, okay, the other ray is going through the center of curvature. So this ray will go back in the same direction, right? And as you can see, these two rays are almost parallel to each other, but somewhere in infinity they are going to meet. Okay, so whatever image they are going to form will be highly enlarged image, and it is the image is formed at infinity, because the rays are definitely going to meet in reality the image will be real and inverted. Okay, let's do the last diagram of concave mirror. Here we have kept the object in front of the mirror, but between the pole and the focus. Okay, between the pole and the focus the object is kept. So when I keep an object between the pole and the focus, what can I see? What can I see over here? I can use the fourth rule of the ray diagram, where I can see there is a ray passing through the pole and that is reflected back. Okay, the angle of incidence, angle of reflection is same in this case, and then one ray is passing through the center of curvature. Okay, the ray is passed to the mirror through, after reflection it is passing through the center of curvature. Okay, and what I have to do is I have to extend these rays at the back of the mirror, and wherever these rays are getting wherever these rays are meeting, there I have to form an image. Okay, here I can see my image is virtual because these rays are not exactly meeting, or in reality they are not meeting at the back. It is just apparent. We are just extending the rays backward, and we are making them to meet backward. So the image is virtual because rays are not meeting at back. It appears to meet at back. There's a difference between between the rays when they appears to meet at the back, or the rays when they are really meeting. Okay, so here in this case the rays are appearing to meet at the back, so the image is enlarged, virtual and erect. Here the image is enlarged, virtual and erect image. This is a very important diagram. This usually comes because this is a very different diagram of concave mirror. Coming to the convex mirror, as we can see here, the first diagram of convex mirror, the rays are parallel. That means they are coming from the infinity, right? They will definitely, after falling on the mirror, will reflect back. As we can see, they are reflecting back again. We have to extend these rays backward. Okay, and if I extend these rays backward, they are going to the focus, because according to the rule, whenever the rays are parallel to the principal axis, they goes through the focus after reflection. As you can see here, the rays are not meeting in reality, so the image is virtual. It has to be erect. It is diminished, as we can see here, and it is found, or it is formed behind the mirror. Okay, now coming to the next diagram of convex mirror. Here we can see you can keep the object anywhere on the principal axis, but not at infinity, anywhere on the principal axis. You have to draw two rays. One ray is coming out of the object and falling on the mirror, reflected back. Okay, I'll extend this ray. I'll extend this ray. It is going through the focus, right? Another ray is going through the center of curvature. Okay, it is going through the center of curvature. So after reflection, this ray is going back to the same path. It is following the same path. So this type of ray always go through the center of curvature, right? And wherever these two rays are whenever appears to meet, wherever these two rays are appears to meet, there I'm going to draw a image. This image is definitely virtual image. It is diminished and it is erect. So the short form is of this image is VED, V-E-D, VED. Okay, V stand for virtual, erect and diminished. So this virtual, erect and diminished, this type of images are always found. It always formed in convex mirror. Okay, in case of convex mirror, you will find this virtual, erect and diminished mirror, whereas in case of concave mirror, you won't find virtual, erect and diminished. This image is virtual, enlarged. Okay, and this virtual, erect and enlarged, V, virtual, erect and enlarged. Okay, and VED is virtual, erect and diminished in case of convex mirror. So we can see the use of convex mirror. It is used for makeup mirror, as a makeup mirror in torches, in headlights of cars, in searchlights, in doctors' head mirrors, and solar furnace. Okay, the sign of convention of spherical mirror. See, the sign of convention of spherical mirror, as we can see the spherical mirror. Okay, so we have to use u distance, object distance, v image distance, f focal length, height of an object, and height of an image, right? So it is very simple to understand the sign conventions. You have to use the Cartesian rule. So this mirror will act like a line. Okay, so I can see that this is nothing but a graph that you are quite aware of, right? This is my x, this is my x, let me keep it x positive, this is x negative, this is y positive, this is y negative. So, okay, so in case of concave mirror, if I consider the concave mirror, every time the object is in front of the mirror, right? Every time the object is over here. So this is x negative. So the object distance is always considered as negative. Okay, there is one more way to remember. Okay, in front of mirror, front, in front of mirror, the things are always negative, right? And at the back of mirror or behind the mirror, the things are always considered positive. Okay, all the parameters that falls behind the mirror consider positive. All the parameters that are falling in front of mirror consider as negative. Okay, on the top of the principal axis, consider it as a principal axis. On the top it is considered positive, as you can say y is positive, and down it is negative. Okay, so if I consider this as an object, right, this is negative. In case of concave mirror, always we keep object always in front of the mirror, front negative. The image, the distance between the mirror and the image can be positive and negative. So most of the time it is negative, or most of the time in the image is formed in front of the mirror. Only in one case where the image is formed behind the mirror, we are talking about the concave mirror. Okay, the focal length is always in front of the mirror. So focal length is always negative in case of concave mirror. Height of an object always positive. Height of the image is always right. It can be negative, it can be positive. Okay, most of the time it is negative, but in only one case it is positive. Okay, if you remember the case VEEV, okay, where the object is placed between the focus and the pole. So this is all about the conventions. Similar convention you can keep for the convex mirror. In case of convex mirror, if you remember, okay, my object is always placed in front of the mirror, so u is always negative, v is always positive. It is always, the image is always formed behind the mirror. We have considered two cases. Image is formed behind the mirror, right? Focus was behind the mirror, so that is positive, right? Then height of an object, it was always positive. And image, height of an image was always virtual, so virtual always positive. If you see, with virtual the sign goes positive, positive, positive. With the real image the sign goes negative, because the image is formed below this line, right? So we have come up with mirror formula, that is 1 upon f is equals to 1 upon v plus 1 upon u. Why we are using this formula? Because we have to calculate the distance, the image distance and the object distance. So if we have to calculate the image distance, object distance, we have to use this formula, right? So without the use of a ray diagram, we can calculate the image distance, object distance with the help of this formula. Then there is a formula called magnification. Magnification helps us to tell that what is the height of the object or what is the height of an image. For that we have used this formula. Okay, magnification is height of an image. It is a ratio between the height of an image and height of an object, okay, which is h dash and h, and which is also equals to v upon u, okay, which is also equals to v upon u. So this is all about the magnification. uh, Here we can write minus v upon u, okay. It is minus v upon u in case of a mirror. It is minus v upon u, and here we can see that h stands for the height of an image, and height of an object. H dash stands for height of an image, and h stands for height of an object. So this is all about today's session, children. Practice today's topic. Thank you so much.